question. How many test cases should we add for lab 0? So as stated in the lab document, if I remember, it's a single test case to add there. But just put in mind that the requirements are like basically the contract between us and you is really the lab manual, right? Unless I state otherwise. So if I didn't comment at all about the test cases, whatever number is there in the lab document should be what you stick to, right? So I believe it's only a single test case because we wanted to show you in lab 0 how to add your own. Like once you add one, you can really add as many as you wish. But put in mind that lab 0 is just a function of a single line, like adding 2 numbers. So what is the meaning of adding 100 test cases for as simple function, right? So it's really meaningless. So I guess one is enough. One thing I don't know if I mentioned before, but I told you, well, we give you few test cases, and this is the usual case for all the labs. We give you few test cases. These are the ones that you can test your code against, right? Then we ask you to add your own. Usually you would be adding at least one test case for every single function you write, right? But then in addition to this, when we grade the lab, we have our own test cases. Well, call them hidden test cases, call them additional test cases, the ones that we don't give you. And they might be testing other corner cases that are not covered, right? So make sure when you write a test case is you cover, because this is also a skill that is very important for industry. It's not enough if you go for a programming interview and they ask you to write a program. You might think the only thing they are testing is really your ability to write C code, like the syntax. But that's really the least important thing. And I have been doing interviews in industry myself, right? That's the least important thing, right? If you do a mistake in the syntax, well, it might not even matter at all, right? But what they are looking for is your way of thinking, how to formulate a problem into an algorithm, how to formulate an efficient algorithm. Like basically don't write a code that seems to be very inefficient, right? And the second thing is your way of thinking. Like, well, you write something on the board or now on a shared doc or whatever, if it's an online interview, but then how to reiterate if there is a bug, because that's very important. Like how to trace your code back, how to discover a bug, how to modify it, how to consider corner cases, right? And then in addition to this, how to write a test case, and you might even like get asked explicitly about this. How to test that code? Assume, well, you wrote this code. Is it all done? We should just put it for production? No way, right? This is not how it works in industry, right? It has to go through, I would say, a very strict testing process. And if you have watched my video on unit testing, which is kind of a requirement for Lab 0, it goes through this process very explicitly. Like it tells you in industry, in fact, they have what they call daily builds, where they run during night a very heavy regression suite, like that tests everything. And also when someone tries to push something into the main repository, similar to what you do as git push, you have to do your own local testing before you do this. And well, most industries disallow you to push anything in the main until you run certain test cases, right? So this is how it works. So make sure you also put this in mind. Good. Yeah. What else? I guess that's all about testing. Do we cover UAT in this course? Please, like, bear my ignorance. But what is UAT? Right. That's just let me know what you mean by that. Okay. Okay. So I will join from the tablet, and then I will share the slide. So yesterday we stopped at the algorithm or the example that is it the example that tries to read from the user until you input 1. Is that the one that we were talking about, the last example? Give me a second. I will join first, and then I. Okay.
Yeah, the last one I have that we were testing is about non-decreasing inputs.
Ah, correct. Like when we use arrays. Okay. Yeah. Okay. Yeah. So we went through. We wrote the code, but maybe in a hurry a little bit at the end of yesterday's lecture. So today we can go through like different, I would say, variants of how to write such code. Let me go first full screen. But before this, well, I still can take a couple of questions. Is it fine if we add more than one test case? Yes, it's highly recommended, Keith, right? As much as you would like. Okay, good. So going back to yesterday example, so we said, well, I want to input from the user 20 test cases, and then here 20 test cases, sorry, 20 integers, and then I want to like determine whether they are sorted in a non-decreasing order or not, right? And we said, well, to determine whether they are in a non-decreasing order, your program should have all the 20 inputs in the same time. This is what is different from this example compared to the previous examples. Excuse me. In previous examples, we were processing inputs as they come, right? So we needed a single variable, and then we just overwritten x every time, right? But this time we need all the 20 on the same time. So we said we cannot use a single integer variable, and this is introduced us to arrays, right? So we said, well, we're going to, this is the algorithm that we went through. We will read the 20 inputs, we will store them in an array, and then we will loop through the array to see if it satisfies this condition, basically, right? This condition can be really anything, right? In this case, it's a non-decreasing order. And then we said to keep track of this while we are traversing the array, we're going to define some sort of a flag that, well, we can initialize to anything 1 or 0. This is usually, flags are usually binary, 1 or 0. What I wrote in the code yesterday, I initialized it to 0, and then I said 1 means it's really breaks the condition. Here it says, well, let's initialize it to 1, and if the condition is false, then it's set to 0. It doesn't really matter, right? It's your own convention of how you write the program, right? And then after the loop ends, that means we have to reverse it the full array. Then we are going to check our flag. The general rule is if your flag it still has the same initial value, whether it's 1 or 0, that means you didn't modify it inside the loop, right? You didn't modify it while you are traversing your array, which means you never hit a condition that your array is not sorted, or generally you never hit a condition that the array breaks your requirement here, which means in this case your array is sorted. Otherwise, if the flag changed, so it was initially 1 and then moved to 0, in that case the array is not sorted. And if you remember yesterday, after the for loop, we added an if condition saying if flag is, well, the initial value, then, well, it's sorted, otherwise not sorted, right? And this is the flow chart that we went through yesterday. So, well, I will not rewrite this today, so maybe we can quickly go through the variants here in the slides. So here I'm initializing my array. I'm initializing my flag to be 1. And this is the I for the for loop counter, okay? And then, well, I'm giving the initial print message instructing the user to input something. I know that these are 20 integers, so I have a loop, and we said 4 here is more convenient because I have a specific number of iterations. And then each time I will scan the input from the user, basically put it in one of the array elements by doing so. And then right now I did step 1, right? This is all step 1, which is reading 20 input and store in the array, right? What is step 2? Step 2 now that I have to traverse this array and check my condition, right? And this is the purpose of the second loop here. Good. So yesterday I intentionally made a mistake by saying, well, if this is a loop, we have an array of 20 elements, then most likely I'm going to start from I0 until I20, or when we wrote the code, I guess it was 5, right? And then someone of you already like correctly said, well, but we shouldn't be really going beyond the array number of elements, because if I have, let's say I have 5 elements here. If I write my code the way we wrote it to say, well, I just jump directly into here. If we wrote the code such that I check the element to the next element, similar to what we have done yesterday. So if I have 5 elements, so I'm checking 0, that's 0, 1, 2, 3, 4. I'm checking 0 against 1 in the first iteration, right? Because like it's A0 and then A1. And then in the second iteration, I'm checking 1 versus 2, and then 2 versus 3. And then in the fourth iteration, I'm checking 3 versus 4. Do I need a fifth iteration? Yes, I have 5 elements, but because each time I really go to the next, I don't need to have this as 5, or like in this case, it's 20 because I'm having 20 elements, right? That's why it should be less than the number of elements by 1. Why? Because here you have something that goes beyond your, it adds something to your count, right? So that's just for this example. But generally in your programming, if you want to make sure you don't go beyond your array boundary, what you can do is look into the expressions in your iterations and see if you add anything to the counter, right? And this will lead you to know what is the exact condition. What I mean by this, here we are just adding 1 to I, so I'm stopping only one element before the end. What if, for example, for some other program, not this one, I'm just adding to I, let's say 5, right? Where should I stop to make sure I never exceed my array boundary if I have 20 elements? What do you think? It should be really your number of elements, which is 20, minus 5, which is the added counter here, because, well, the rule is this: if you use this as your index must be less than your number of elements, which means your I must be less than 50, correct? This is how you get it, right? So see what you use as an index. This expression should never exceed the boundary, and then from there you can get the condition for your counter, okay? Remember, that's very like that's very important because it will come also in few labs. It's like usually a very common mistake in C is that you exceed your array boundary. In Python, if you exceed your array boundary, you really get a compiler error, so your code will not even run. But as we will see in the another array lecture, when we explain in detail how the arrays are getting allocated and what happens in C, C does not tell you if you exceed your array boundary. Why? Because, well, C gives you more responsibility as a programmer. Well, C assumes you know what you're doing, right? So it allows you to go beyond your array boundary, and this is very risky, right? You have to handle it very clearly. Okay. So going back to the main question itself. So if I have 20 elements and then I'm adding this one, so I'm going from 0 to the last minus 1 element, I'm checking if the current element is larger than the one after. Well, that means I really broke my condition, right? Because we said it has to be in a non-decreasing order, right? Which means for all the elements, also as we tried yesterday, each element should be less than the subsequent, less than or equal the subsequent one, right? In this case, if it's larger, you broke your condition, so you change your flag, right? Put in mind, as I was saying, it doesn't really matter what value is this. So if you initialize to 1, you just change to 0. Yesterday, we initialized to 0 and changed to 1. That's a convention, right? Because how you interpret your flag, this is the way you kind of interpret it. And a good practice is really you have a comment that says, well, this flag is used to determine whether we broke the condition. It's initially 0 or 1, but then I change it to 1. Like you add some sort of explanation to your logic, okay? But then at the end, that's exactly the variant we wrote yesterday, which is check the flag. Well, if it's still at the initial value, it's sorted. Otherwise, it's not sorted. Good. Is there any question with this variant? Because we are going to play around with that. It's clear? Okay. So let me see if there are questions in the chat. And if we add more, than I guess I already added this. How many? Okay. So now, one thing we said yesterday and also on Monday about for loops is in C, for is more expressive than the Python case, right? So it gives you low-level control, so you can really modify your 3. So we said there are 3 statements in the for header, and I can play around with them. For example, here, if I go back to my original variant, well, if I break my condition, I set to flag to 0. One question to you, do I need to continue checking the other elements? So for example, if I have 5 elements here, and this is 4, this is 1, and then, well, I have 10, 11, 12. Once I check this one, I found this one is larger than this one. Do I need to continue? Even if the remaining array is sorted? Well, I just broke my condition, right? Which means, well, this array is not in a non-decreasing order. So once you determine, you break your condition, you can just exit the loop, right? Because there is no point of really continuing it, right? You already didn't meet it. Is that clear? And yesterday, if you remember, I guess we did a break statement. We said, well, we no longer need to continue, right? So you can really just add a break here. But a different way of doing it is to say, well, I'm going really to add my flag to the condition of the loop itself, instead of adding a break. So we say, I'm going to continue in my loop as far as I is less than 19 and my flag is still 1. If I detect that my flag changes to 0 at any moment, well, I no longer need to continue. Good. And then you just exit your loop. This is equivalent to a break statement. Good. Why do we do this? Why we need to save continuing that? Well, what is the harm of just continue checking the array? It's still correct, right? Right? What do you think? Why we bother just complicating the condition or adding a break statement or adding additional code? Slower, exactly, yeah. So it's more redundant work. That's a work that is not really needed. And we were talking about efficiency of code, right? So once I determine something, assume, well, these are 20 elements, so it wouldn't really matter. But assume you are checking the, like whether a data structure that has millions of elements, whether it's sorted or not, right? And maybe the first 2 elements already gives you the condition. I don't need to continue because I'm going to save the running time, right? So it's slower definitely if you continue. It's unnecessary work. Okay. Good. Well, that's the one that we also tried yesterday, which is just adding the break statement. As we said, this is completely equivalent to this one because here I break if the flag changes to 0, and here also I basically don't enter the loop if the flag is not 0. If the flag is not 1. Okay. Good. So one thing, I don't know if you tried yesterday, if you got the time, but one thing you should be trying is variant 4, which is trying the while loop. Right? This, like the same example, can be rewrote completely equivalent using a while loop. Okay. In fact, once we start introducing conditions here, similar to this thing, so maybe while becomes really more convenient than for, right? Because while allows you to have the condition in a more compact way. Okay. Good. Is there any question about these examples? So again, the main purpose of these examples is, well, I personally believe the right way to teach a language is just, well, let's implement some stuff, right? Don't go through rules first. Let's implement some stuff, and then from there we can really learn some of the syntax and what are the rules. And later on we will go to the boring rules. Okay, but I hope before we start the actual like exact rules and go through all the process, you should be at least either trying those codes on your own, like just code them and try them out. That's the best case. Or at the very least go through the slides, right? Because later on I will assume you guys kind of went through these slides, right? Good. So if that's all good, there is a question. If we had left the code like this, could flag equal be overwritten, flag 0? So okay, let me quickly look into this. Oh yeah, that's slide 36. So could flag be overwritten by flag 0 if there were 5 integer inputs, 5, 8, 7? So 5 is because it would have gone back through the 4 back through. I'm not sure if I'm getting, well, yes, it will be really overwritten because 8 is larger than 7. So you break your condition, Emma, right? So if you compare 8 to 7, 8 is larger and then flag will be 0. Can you go through variant 2 one more time? Sure. Yeah, no worries. Add the line with red. Okay, so I guess, yeah, well, there is a question about also this variant. So let's quickly go through it. So here, first of all, the thing you need to know is without this condition of flag, the program is still functionally correct, but might not be the best efficient one. Because what we are saying is once your flag changes to 0, you got what you need, right? You don't need to continue further in your program. And to understand this better, maybe we'll go through first one thing that is similar, which is break thing. So we say if the flag is set to 0, I broke my condition, then I'll just break. Break means exit the loop, right? So if you understand this variant, going back to this one is similar now because it does exactly the same thing. It says, well, I continue in my loop as far as, well, I'm still within the array boundary, but on the same time, I didn't change the flag at all. So if in one iteration you changed your flag from 1 to 0, you will not continue, right? Quickly trace this. Again, this is something I advise you to do. If there is a code that you don't understand, or if you are debugging a problem in your code and you are not really getting it, a very good skill is to just assume a certain input use case and then go through it yourself. This is called program tracing, okay? This is very good for debugging. So assume we have, well, I will take the input of Emma for sake of explanation as well for her question. That's 58731, okay? So if I have this as an input and assume only I have 5, not 20, what happens? I will go through from beginning. Is 5 larger than 8? No. So I'm not setting flag to 0. So in the first iteration, flag is still 1. In the second iteration, is 8 larger than 7? Yes. So flag is set to 0. If I come to go through the third iteration, I check my condition. But this is saying only enter the loop if flag is equal to 1. But flag is not equal 1 here. So I just exit. This is how it works. Okay, I hope this explains. Thomas, why not implement the flag as a Boolean value instead? That's an excellent question, Thomas. Well, that's good for Python, for C++, for Java. C is a Bool language. They don't have a Boolean type. Good. And we will go through this when we talk about types. There is no inherent Boolean in C. Booleans in C are operated as integers. And usually we'll discuss this in detail. But simply, a 0 value means false. Anything else means true. Right? So we will have a separate lecture for this, but that's a good question. Okay. Good. So now let me switch slides. Okay. I have already uploaded those slides to Avenue for those who came late. So you should have access to them. So the good thing now is by starting some of the more, I would say, concrete rules rather than just having hands-on, we have already used functions, right? So I told you that main is really a function, a typical function. It has exactly the same thing as a function. It has a return value, the name, and the input parameters, but there are no input parameters. And then we have also used other functions we didn't implement ourselves, like printf and scanf, right? Also in lab 0, if you see, we have structured the code to operate as functions. So everything is modular. So for example, the question1.c or the question.c, the add function is called add function. And then, well, it takes input parameters from the test case, right? That's something good to link the lab to the lecture. So let's look into this. So in the test case file, I guess it's test cases.c. And this is your question. It's called questions.c or question1.c, I don't remember. But here we implement, in fact, there is a third file, and I'll also, I guess it's very useful for today's lecture as well, which is questions.h, the header file itself, right? These 3 examples from lab 0 well explain one of the most important things for today's lecture, which is a function has really 3 things, right? It has what we call a prototype, which is the first line of the function. And you will find this prototype in your header file. Usually it's good to include definitions in header files and implementations in source files. This is a good programming practice in C. C has header files and implementation files. Header files only include the function prototype, and C files include the implementation. If you remember in our previous examples, by printf and scanf, what did we include at the top of the program? It's studio.h, right? So we only included the header file, right? So if you want to use a function, it suffices only to include the header file that has the prototype. Also, if you look into test cases.c, the one that calls your add function implementation, you will find it only includes the the question.h or questions.h, right? The header file. What do we have inside this header file? Well, it's a single line of code, right? So what it has, it's add, well, I guess you return int, and it has int add function, and then it takes as an input two input parameters, int input 1, I just call it I1, and int I2, and then semicolon, right? This is called function prototype, right? What do we mean by this? It dictates the signature of the function. It tells the user, what do I return, which is here an int, what is the name of the function, and what are the number of inputs and their types as well, right? So as a user for this function, I only need to know this signature to be able to use my function, right? I really don't need to care about the implementation. Reflect back on what we have done. Do you know by now how printf is implemented? We don't know, right? Like if I asked you, like, tell me the logic of printf implementation, well, we didn't look into this, right? Most likely it's calling some input output registers, deal with the screen, but we have never looked into the implementation. But we were able to use it. Why? Thanks to this kind of signature and prototype of the function. You only need to know how to use it, right? This is why we isolate it in the header file. That's the first element of a function. What is the prototype? Good. Then the second one, well, let's leave this for end. The second one is the call. So this, we call this signature. This is the call. And the call is when someone wants to use your function, right? And we have used the call for printf and scanf again, right? So if you look into test cases.c, you will find the test case you wrote yourself, right? Even if you copied the code and then modified it, but well, you wrote yourself, right? So that's basically you found a call to an addf or add function, and then you pass some values. I guess you pass actual and expected, right? So you pass, let's say, actual, expected, and then you take, well, no, sorry, actual and expected is for the output, but I guess you pass input 1, input 2, or you can just simply pass numbers, in fact, if you want, right? But then here, this is the actual one. You take as a return value, you set what is the expected value, and later on we compare the expected to the actual, right? Isn't this what has been in the test case, right? So simply you do a function call to the code itself, you pass some inputs, you know by design that if I pass these inputs, if it's a correct functionality, I'm expecting, for example, if I'm passing 2 and 3, I should expect 5, right? This is your expected value. And then you pass to the function call, you get the value back, you compare it with your expectation. This is how you do testing. This is called the function call, right? What do you do is simply you write the function name and you pass the correct input of parameters. If the function returns something, then you take this to a certain variable, right? Printf and scanf, they had no return, right? So if you look into our implementations of printf and scanf, we really didn't take the value of the output to something. We didn't have something on the left-hand side here. But if you look into add function call in test cases.c, you take it in a variable. Why? Because if you look into this implementation, addf returns an int. But if you look into the signature of printf and scanf, it returns void, so it returns nothing, right? Good. So this is the second type. So we said that's called signature. This is called call. And the third one is what? Like, well, you have the signature, but you didn't implement anything yet, right? That's the actual implementation of the function, right? So the third one is implementation. And this is the actual logic of the function. For the add function logic, it was a very simple one. Well, it can be a single line or a couple of lines, but simply what you do for the implementation is also you write the exact same signature, right? But without the semicolon. You open brackets and you implement your code. In our case, well, you just write it here. I'm not going to write it because lab 0 is still is not done yet. But basically, you just add the two numbers and you return them, right? So this is called the actual implementation. Until now, all the examples we have done, we didn't really implement any function except the main, which is the one that we wrote, right? But what we'll see in this lecture is we see how we add functions and then implement them and how we call them. And I guess, well, by doing lab 0, you should have some familiarity with this. Good. So just to summarize this mess in the slide, we have three things for a function. We have the prototype or the signature, which dictates what are the return, the name of the function, the input parameters. We have the function call, which is basically the use of the function itself, right? And the third thing is the implementation of the function, the source code. Good. So now the question is, why do we really need to write functions? Is it possible from a functionality perspective to do all the logic of the code in just a single function in the main, for example? Yes, it is, right? So you can really implement anything from a functionality perspective. It doesn't add anything. I can write my code in a single function and done, right? But this is, again, not a very efficient way of doing it. Why? For multiple reasons. The first one is, well, what if you want to write the same logic for different purposes, right? So for example, printf. Are you going to printf exactly the same thing every time? No. So that does it mean that, well, every time I want to implement something, I need to repeat my code but take a different input? But that's not very efficient, right? So the proper way is, well, you have just a common implementation that is parametric, so it takes certain inputs and it behaves accordingly, right? This makes your number of lines of code shorter. It makes it more readable, but most importantly, reusability, right? We didn't need to printf. We didn't need to implement printf ourselves. Why? Because someone implemented it for us, right? At the same time, you didn't need to implement uh, all the functionality of the test cases yourself to be able to use it, right? Because I gave it to you. So adding functions allows you to pass your function to someone else to reuse it, right? Think of what if you wrote all your code in just a single function. Can you share part of your code to someone else and then ask them to modify it to suit their needs? Well, that's very hard, right? You might not even able to read your code maybe after a month, right? Because you might have thousands of lines of code. Good. So functions is very important for reusability, for readability, and also for code maintenance, right? And functions, well, it's not object oriented, but functions may be the building block that later on we will see when we add classes and objects, etc. It's very important to have a modular code, right? So it's a very important concept. If you go to a software interview or even hardware one that asks you to write a code, and then you don't make use of any functions, and then you kind of need to re-implement everything, have a very large line of code. Well, put aside that you will not be able to finish your code within the allocated time because you will need to repeat many things, but on the same time, it reflects a way of thinking. You are not able to abstract that, well, this code is very common, let me implement it on the side, and then I'm going to recall it, right? Good. So let me pick questions and then we will continue. Question, why is this is question related to previous thing? Can you go through? I have a read on this. Does the for loop in the C increment I before checking the condition? Ryan, I will answer this question because we already left the topic, but I will answer this question when we talk about for loops. Like, it really depends. Like whether it incremented after or before, it depends on whether you do I plus plus or plus plus I. So it's a little bit of a detail, but I will come into this when we talk about loops. Okay. Thomas, why not implement the flag? Oh, I already answered this. Siegfried, what does addf mean? Could that be replaced with the void in the lab? Oh, addf, well, this is the function name. It's called add function in your lab, but because my font is very large and the slides will not accommodate this, I just called it anything, right? So it's basically the function name, right? And it cannot be replaced by void, like with void in the lab. I'm not sure what is, like basically void, if you put a void, that means the function does not return anything. But in our lab, add function must return an int, right? So you cannot really modify the function signature. Good. Okay, good. Okay, we went through all of this and we said these are the three main components: the function call, which we have seen in printf and scanf, function definition or signature or prototype. This is the header file thing, and function, well, this is called function definition, but maybe I would just prefer implementation as well, right? But sometimes referred to as definition. This is called usually prototype, or you might find in some places signature as well, right? This is really a more proper word from software engineering perspective, or declaration is another word, right? So let's see now an example, okay? How much time we have? So So yeah, do we go and implement this? Let's see. So maybe I will just jump into online GDB and see if we can play around with some code. So I will stop sharing here, then I will share that one. Okay, so right now let's assume we want to write what it is. Like I want to write my mean square, right? So I want to take two floating point numbers and find their mean square, okay? So how to do this, right? So let's first say, well, I will write everything without a function for now, and we'll see if we are going to implement it in functions, how it goes. Well, first of all, I want it to be floating points, so I'm just defining the type double. I call it input one. But right now, if there is no function, let's call them something different. So A may be 10, similar to the example, and B is 20. And then my output should be in C. And then if I'm writing this code in main, well, what does it mean really to have a mean square? Basically, to have a mean square of two. Well, do you guys remember this from first year on maybe high school math, right? To get the mean square of different inputs, you just square all the inputs and then sum them up and then take the. Well, if is this mean square root? No, there is no roots. You just take basically the average of the means, right? So the way to do it is say, well, I want to get my. Can I just overwrite A? Yes, but maybe I don't really need to do this. So I say A multiplied by A, and then B multiplied by B, and then B asterisk is the multiplication in C, right? And then I just divide this by 2, okay? That's a single line implementation. But well, again, if I assume right now I want to get the mean square of different numbers, like something else, like something as let's say like D and F. What do I have to do is I would say double D equal 15. Well, let's just keep them floating point, and then maybe E is equal 25, and then F is our output, and then I would have to repeat this line of code for F as well, right? Because this will not work for this one, so I have to replace this by DD.
Professor, after E, take away the semicolon and put it.
Correct. It should be just comma. And then E, and then E. Okay. So the main point here, given that even if this is a single line of code, well, I just combine multiple expressions in the same thing. I could have just squared A first and then B and then divided, but doesn't really matter. This is a single line of code, but it can be more involved than this, right? So in this case, you have to repeat your logic, basically, right? But if I'm going to implement this in functions, it just suffices to say, well, I already have a function that takes two inputs. It returns to me a double because mean square of two numbers will basically be the double. And then I will going to call it, I don't know, my mean square. And then right now I'm writing the signature, right? And then what do I expect as input? It's double input 1 and double input 2. By the way, for the input parameters, these are variables, right? So they can be called any name that is legal name. You can call them, well, that's Muhammad and this is Hassan, right? Anything, it doesn't really matter, right? But the point is, I usually call my input arguments as like inputs. You will see this usually in the test cases as well, to just put in mind that the naming reflect some kind of what is the functionality of this variable, right? And then that's just basically the signature. Usually, if you are adding the function in the same file as the main, it suffers to add the signature in the top, and then later on you can implement it. So we can do something like this. We said in the implementation or the definition, you repeat the first line, then you add your brackets, and then you just implement your stuff. I'd say double output simply will be input one plus the input 2, then just divide by 2 here. And then I return. Okay. So this again can be written as multiple lines of code. Something I can do, I guess you would see in the slides, is maybe you can even overwrite input 1. Say input 1 equal input 1 multiplied by input 2. But let me first try it before having variance. I want to keep it in the simple format. But that's basically the function implementation. Good. Right now, to change the main, what simply can I do is say, well, C will be evaluated to the function call square, my mean square, and then I'm passing what? A and B, right? In fact, even in this case, I can just pass 10 and 20 here, and we will also try this later on in our variance, okay? And then well, F would be exactly the same thing, but then this has to be D and D. Okay. Going back to what we discussed, the function right now has 3 things, right? The signature, which here I put in the top. Usually you should put this in a separate header file. The implementation or the definition, which here I put down, which is the actual logic. And this is a function call that usually happens within another function. Good. So if we try this out, let's see if we have any problem. Well, oh, that's a typo. Should be just that. Well, yeah, I didn't print anything, which is bad. So that means, well, everything executes, but well, I no longer see the value. So something I can do here is say print F. Originally A was, well, that's double. And then B was another specifier, and C equals, well, there mean is, and then this should be well, another double. Then here I just pass A and B and C. You can do exactly the same thing for well, F, D, and E, right? So I just copy this. Then here, this should be what, D, E. This should be D, E, F. Okay, and then I just run. So A is 10, B is 20, and their square mean is, well, that thing. And then D is that, E is that. Well, I didn't really properly format it. I should have a new line here, right? Such that it looks good, right? And then their square mean is that. So in, well, one, well, let me first take questions before going into variance. I usually tend to optimize, but let me stop. So are there any questions about this code? So basically what we have done here is, again, we have done very simple example of the 3 main things of a function. It's prototype here, determining the inputs, 2 doubles, determining the return value, which is another double, and that's the name. Implemented it to achieve the logic we need, and then we just called it here, right, twice, right? Can you write the function definition right under the function prototype? I will come into this, Sufi, but that's a good question. So if you are writing it on the same main file, in fact, if you just take the implementation here, just suffice to do this. Just have the complete implementation before the main, right? And if you run well, it should just work fine, right? We said the proper way of doing things is you really have the signature in a header file, the implementation in another source code file. You can call it my main square.c, for example. And then inside the main, you just, well, am I able to really include files here? Let me check this. If online GDB allows me to do this, this will be good. I call this my mean square.h. Let's say okay. And then I will just take, let me go back to the original one. I just take the prototype here. Then I will add another file. I'll call it my mean square.c. And then this should have my implementation. I'll just cut this one. And then what should I do in the main? What do you think? Now I added the header file having the prototype, like the signature. I added a source code file having the implementation. I want to use it in the main. What should I do? What do you think? Well, here I'm already calling it, but would the code recognize it? Let's try. Well, it tells you implicit declaration of a function. It doesn't recognize it. Yeah, I have to include it, right? But Arthur is saying, well, include, but do I include the source code, the .c, or I include the header? What do you think, based on what we said? Like, should I do like what Arthur is saying, include my mean square.c? The header file, exactly, yeah. So that's similar to what we were discussing about the lab. If you look into test cases.c, we include questions.h, right? Also here, we include studio.h. So usually you just include the header files, okay? Good, so if you do this, this should go away. Why? Because right now the main, when the compiler executes this, what happens? Let's maybe go a little bit of detail. We said that the compiler starts executing from the beginning of the main, correct? It goes line by line. Here, well, variable definition, very easy for a compiler. Here, a function definition. If you remember in our second lecture, we said the C compiling process starts, what is the very first step in the C compiling process? Do you recall? We went through like a flow of what happens through the compiler. What was the very first step? Does anyone remember? It was the preprocessor, right? So if you remember, it was the preprocessing stage. And we said the preprocessor will replace any header file with the actual implementations, right? This is really what the compiler will do as well. Here, it will find the header file. It knows that you are using the source code from this header file. Then it goes to the header file, puts the function prototype. So it replaces this code with the original code we had in the main, right? Good. Is that good?
Why does it go to the .c afterwards? Like, how does it know to go from the .h to the .c?
That's a very good question, Mikhail. Thank you. So basically, usually, the headers and the source files should be exactly in the same path, in the same directory, right? Again, if you look into your lab, all the files are in the same directory. Usually, the compiler assumes, unless you indicate otherwise, it assumes two things. If you just call a header file, first of all, if you call a header file from the C library, the C standard library, it knows where to find them because you add your path, for example, in the Lab 0 setup, you add your min.gw if you use Windows or the Xcode compiler flow if you use Mac, but you add this to your system path, right? So simply the compiler will know where is the C standard library header files. But your own header files, if you do something like this, the compiler will assume they are on the same path. They are in the same directory, right? Unless I write something like, well, this header file exists in C something, 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 right? So it will have to fetch it from this path, right? That's the first assumption. If you don't provide any path, it's exactly the same one as the current directory. The second assumption is that all header files will have associated source files in their same directory, right? Here what we had is you can assume these three files are exactly in the same place. So the header file is that, well, it must have an associated implementation. Otherwise, the compiler will complain, right? And it has to be in the same directory. Again, if you go back to lab 0, that's the example you have. Questions.c and questions.h are both in the same directory, right? I hope this answers your question, Mikhail.
Yeah, it does. Thank you.
Don't we need D? Oh, these are doubles. So I use a different specifier, which is LF for long floating point, okay, or double precision floating point. Abdul Nasser, don't we need to define the output variable? I already defined this. For like here, I defined C as my output. I take here, and if the same thing, if you go to the implementation, I already defined the output to be double, right? But I defined it and well used it on the same line. Another way to write it is say just define output and then use output, right? That's maybe a more standard way of doing it. Good. Wang. So C doesn't run line by line. It runs line by line. Yeah, that's definitely the case. But upon line by line, if there is a function call, this is called usually a jump in the code execution. If there is a function call, it goes to where this function is being stored, right? Okay. Does the word double have any specific function here? Shahab, yes, that's a variable type, right? So similar to the ints we have used before. Even yesterday we used double as well. When you define a variable in C, you first have to declare it, and by declaring it, you need to determine what is the type. Here is double. What is the name of the variable, and if you want to initialize it. So double here means what? The type of the variable. If you mean what double means here, it means this is the return type of this function. We said a function signature would have to have, well, it's a good way of doing it. So a function signature would have the input parameters and their type, the name, and the return value. Good. Yeah. So well, a header file. The question is, what is the difference between header files and source files? Usually, header files don't have implementation. They don't have logic, source code. They only have variable definitions and function signatures. Good. So you can think of header files as the interface, something that if you want to give your code to someone and he or she wants to understand how to use it, header files would be enough, right? And then C is the actual implementation. C is the dirty work, right? So basically, this is what should be hidden from the users, right? Good. Okay, so let's look into the slide and see what variations do we have. We went, yeah, this is some kind of theoretical info. Maybe we can go through here. So going back to the slides. So here, well, it gives, we went through some example. Hopefully we know this by now, but this is a general rule. So simply a function will have the return type, the name, and the parameter list. Good. And basically this might be the actual implementation of the function itself. The return type, well, what do I return? If you don't want to return anything, you just put void and means, well, there is no return, right? One problem with functions is you cannot really return multiple values. So what if you want to operate in a function and the functionality itself would output few variables, not just a single one, right? There is a hack to do this. There is a way to do it, but the traditional way is that a function can only return a single variable, okay? And this is why you have here a single type, which is just double. So it means a single double value, okay? The function name can be any valid name. That's fine. The parameter list would have also variable definitions, including their types. You can put a void if you don't have any parameter list. We tried this in the very first example with main, or you can just leave it empty as we do in our code, right? Both are fine. Another thing is you cannot include a function definition inside another function, right? So function definition, because functions are global scope, they have a global scope. They can be called from any other function. So you cannot define a function. Going back to our code, I cannot put my implementation of my mini square inside the main. It has to be outside the main, right? Whether in the same file or a different file, it doesn't matter, but it has to be outside the main block. So it has to be in what we call the global scope, okay? Function prototype. Well, that's the signature. We have went through this. These are few examples of signature. Well, you can write it like this in C, which means, well, I don't really take variable names. It can be anything. One important point we already said is that the function prototype should match the implementation. For example, in my main square function, I cannot write the signature in the header file that it takes only 2 input parameters. And when I go to the implementation, I can just take 3 inputs, right? It doesn't work. So you have to match, and we will try, maybe we can try this trick in the code now to see what error do we get. So basically the main rule is your signature should match exactly your definition, right? Otherwise, well, it's a different function. Okay. Okay, function call, we didn't. We went through the call. Okay. So here, well, that was one example we have already done, is that when you call a function, you just write the name, you pass the input parameters, and then you return the value if there is a return a value to a variable. Here, that's another example of a function call that we tried using printf, but printf does not return anything, so I don't need to take the output to a variable. If you can think of this string here is really your input parameter to the printf, right? Yeah, okay, so this is now like I guess also, oh, we already passed the time by 3 minutes. You guys are patient. Yeah, thank you. So maybe, okay, so I will stop here. So basically at this point, what we will go afterwards is we will see what happens behind the scene, right? So what happens in hardware when you declare a function, what variables are being defined, how the memory changes, because functions go to different stack regions. So we will understand what happens in the hardware. But we will stop here because that's a topic that will take some time, and then we can continue next time. Again, similar to every other time. Thanks. You can leave if you have something else. I will stay for a few minutes to take questions. Okay. Thanks, everyone. Does the .h and the .c need to be the same name? Yes, they must match the same. Otherwise, the compiler will not know that, right? So they must match. That's also a good point that I forgot to mention. Thank you, you. Yeah. Yeah, well, we have until 11:30, but there is a 10-minute kind of room, Tina, to move between lectures. So I'll give you this time. Thanks. But I'm staying for questions if you have any. Can I ask about makefile? Yes, if you're asking about the makefile we use in the lab, so make is a process that usually simplifies the compilation. Well, that's something that a little bit advanced, but basically the main point is the way we auto grade your code, the way you see the check mark, the green or X in your get interface, is really we have a makefile that you're instructed in lab 0 that you should never touch, and the GitHub we program it such that it runs the makefile to compile your code, run it, test it across the test cases, and give you the output. Okay. But if you have a specific question, Arjun, maybe we can take it last to make sure if there are other more related questions to the lecture, and then I'll be happy to assist you. Another thing is you can just come to office hours and or even email me, and we can talk about that. What is happening in our tutorial tomorrow? Tomorrow in the tutorial we are covering lab 1 because lab 1 is starting this Monday, right? So tomorrow before the tutorial I will release the lab document for lab 1, and the tutorial will also cover this. Another thing I will do also before the tutorial, I will make sure I prepare the videos similar to what I have done in lab 0. I hope those videos were useful. I will prepare the videos from my own tutorials last year to guide you through also lab 1 and any related material. Okay. The other thing is make sure you submit lab 0 by tomorrow midnight, because well, this is an auto programmed in GitHub. So if you don't submit by time, well, the GitHub will not accept, right? Or even if it accepts, it will mark it as late, so it will not appear in our flow, right? So make sure you submit within time. Can we use Eclipse to code without needing to have the binaries and files from the labs? Binaries and files. There are no binaries at all provided from the labs. Oh, I guess your main question is if you want to open a new program in, like, just create a new C program in Eclipse and code into this. Definitely you can do this. We have really done this in 2 lectures ago, but I stopped using Eclipse because I keep using printf to guide you guys, right? Eclipse is not very good with printf, but definitely feel free to use Eclipse for your own coding. That's definitely recommended. Yeah. The Wang, can we just include the implementation of the main in the main.c file? Yeah, this is what we did first, right? This is the thing that we started with, is we implemented my main square inside the file of the main. But then I told you to be more professional, it's good to have multiple files, headers for signature and source codes for different function implementations. Okay. Well, Sana, if you're talking about editing the make file, I'm not sure if that's the case, but never edit the makefile. If you do this, you lose grades, right? And you are highly instructed in the lab 0 document and every single document, don't touch the grading flow. That's very risky to do. Might be you will not pass the GitHub. Yesterday I was investigating this issue with another student, is that he accidentally like changed one thing and he kept failing the GitHub auto grading, right? So don't touch this. Only touch the files that you are asked to do, which are usually contained in the questions source files. Okay. When I run my code, it says launch failed, binary not found. This is a problem that I guess is better addressed by sharing screen during office hours, right? So I guess there's already a running office hour right now. Please like drop there and share screen and we will be able to help you. How many? I'm running into an undefined reference to this thing. What does it mean? So how many? This is exactly the same problem I got when I tried it to like on the 2 lectures ago. And basically what you should be doing is instead of including studio.h as like in this larger than, smaller than brackets, you can just try double quotes. Eclipse seems not to like those, right? Is lab 0 due 11:59 today? No, 11:59 tomorrow. So it's midnight Friday. Okay, that's a good question. But it's already very clear in the lab manual, I would assume, right? Tyler, in lab 0, when I tested it, it returns okay for all tests, but when I push it to GitHub, there is red X there is instead of a green check. This shouldn't be the case at all, Tyler. If that's the case, maybe you can just hit the X unless you didn't push everything, right? But if that's the case and you did push everything correctly, you can click on this X red mark and it will tell you exactly what test has failed. Okay. If it still persists, please come to the office hours and then we'll look into this. But just to make sure, there is no way you can really pass locally and fail in GitHub. We did the environment in a way, unless sometimes GitHub complains there is no enough quota for running code, but that's something that will not happen definitely for lab 0. Okay, questions. The one. I was creating another file on Eclipse, but when I built the project, it doesn't recognize the studio.h file. Yeah, so what I was saying is maybe replace those larger than and smaller than brackets with the double quotes, okay? It should be able to recognize them. And if you want to implement something as like to experiment with in code in Eclipse, create a new project. Don't create a new file in the same project, okay? Like don't modify the lab 0. Like for example, when I tried 2 days ago, I created a project called lecture 2, and then simply I added files there. Hopefully by next lecture, we don't need printfs and scanfs for debugging. I will also use Eclipse during the lectures to make you more familiar with the flow. Okay. Good. Thanks everyone. Thanks Tina, and thanks everyone. If there are still questions, Jack, I guess I see your hands up. Do you have a question?
Yeah. It's just about the material before when you were talking about, I think it was about the header file. I saw something about defining the input types, but not defining an input variable. So in a header file, do you need to have an input variable or just the input type for the variables, if that makes sense?
Yeah. I guess if your question is if I want to define my variables in the header file, right? Not the functions, like the variables themselves. First of all, you need to know that if you put this in a header file, those will become global variables. Later on, we will discuss the difference between global versus local, but you are not recommended to define too many global variables because global variables basically are visible to everyone. But if it happens, yeah, sorry, please go ahead.
Yeah, I'm just talking about like when we're defining a function and we're defining the inputs for it.
I see.
Yeah. Do we just need for the input variables, just their type or their type and what we will be referring to them as in the C file?
I see. Yeah, so I guess this was in one of the slides here. Okay, I see your point. Yeah, well, the standard way, I guess you are referring to these two. So I guess the standard way is to do this, which is you define the type as well as the name of the input parameter, right? That is going to be used inside the function. This is, well, sometimes this is being defined, but it's not very common, and it seems to be also confusing sometimes, right? So I would say stick to the first one. We just put it here because we want to comprehensively cover all the rules. So this would still be accepted, it's fine, which allows you to define the variable inside, right? But I would say don't do this. It makes more
Gotcha.
sense to really define the type and the name as well.
All right, thank you.
Matthew, please go ahead.
Hi, I just have a question. It's kind of like kind of unrelated to what we were doing today, but I was just looking through because we were solving to like the square and then of like the values we were given in our return, like our answers, like that we used with the printf, it printed answers with like 6 decimal places afterwards. And I was trying to use round, but it didn't seem to work. So I was just curious. So C is a less intuitive programming language, correct? Like compared to like Python?
Well, it depends on what you mean by intuitive. I will answer your technical question like the first one, but let me first comment on the intuitive thing, right? So I would say it's less high level. In fact, it might be more intuitive than Python itself. Python is easier to use, but it abstracts so many things, right?
Okay.
While C, well, it's intuitive, but you have to take control of what you do. So it puts more responsibility on you. If you talk about rounding, well, you can still round and do seeding and flooring, anything you want to do in math. You just want to include the correct proper header file, which is math.h in the C standard library. So this allows you to use different functions. About like the printed 6 decimal, like decimal places or more or less, this is also something you can really control in the printf. This printf is really very powerful on this. And later on, we will have few examples of really how to determine how many points I want afterwards, what is the space, how many points I want before the decimal point, and how many after. So you have a full control, right? So so maybe if you just wait, I guess, for a couple of lectures, we will revisit that. Okay. But about using math for rounding, you can definitely do this, but I guess you need to include math.h. That's one thing, and you need to use the correct function name. Like if you look it up, how to round in C, it will give you the proper function name for the syntax. Yeah, thanks, Matthew.
Okay, thank you.
In Python, by the way, I guess math functions are just can be called by default because all the math libraries are like loaded for you, right? So math deals with people like as if, well, they are less in well, it's good entry for learning programming because it's easier. Like usually this is why also it's covered in high school. But if you want a much better understanding, a deeper understanding of really programming, what happens behind the scene, how it interacts software versus hardware, then Python will not help you with this, right? So good C programmers will not find at all any problem learning Python well. In fact, they find it like handy. But good Python programmers are not necessarily good professional programmers in C or any other language because it's very, very high level, right? You see this over the internet. People might be mocking Python programmers for some reason. Well, that's anyone can use it. It's not really for professional programmers. But my personal perspective is you have to be pragmatic. Whatever like programming language works for the use case you have, just do it, right? In fact, in some of our research, what we do is, well, if you want to manipulate files, Python is very handy on this, and C is really very restricting. So we just use Python. And then there are flows that you can integrate Python and C code on the same program, like in the same project. So do whatever you feel is better for your use case. That's what is a good, I would say, engineer is. Like basically, you don't focus on a tool, you rather focus on the target and you use the proper tool, right? Yep, thanks. Haumin, how come only one of the printf? So Haumin, I will make a comment, but it's not really related to your question. You just reminded me of this. So guys, please, like if you have a problem with the lab, just sending me a picture on the chat on Teams. I will not be able to help with that, right? First of all, because I don't know the context, I don't know the bigger issues. And at the same time, if many of you does this, I will not be able to respond, right? So we said there is already I would say a dedicated channel for how to communicate questions. We said like the office hours, the lab sessions, and then emailing the main TA, right? And then if you didn't get the response within 48 hours, you just forward the problem to me, right? Any technical problem, it's better addressed not by like snapping a picture or print screen. It's better address if you go to office hours and share screen. Again, how many, this is not related to you because we're in a lecture and I can really look into this and it's a very specific question, but I'm talking about those who are facing problem with the lab, right? It's not the proper way of seeking help. You have to go to office hours, and there we can like share a screen with you, see different steps, and it's much better than just a picture. Okay. Now going back to your question, looking into here, and then it says, how come only one of the printf is giving an error? Well, it depends on what is this error. Well, that's also a typical example of like the picture doesn't tell the full story, right? So it depends. Like maybe you didn't define C. Maybe C is of different type, right? If C is double, most likely you need an LF, not F, right? And sometimes it just stops with the error at the first one that it encountered. So it might be both have the same error, but it just shows you the first one, right? Yeah, Jack kind of answered you, but it's LF, not FL. Just so long as we committed and pushed everything to GitHub, the lab is considered submitted. Yes, yes, Kaiden. Yeah, that's correct. Okay, so I would say thanks everyone, and I will see you next week, and all the best with your Lab 0 submission. And yeah, thank you.